Hi everyone. Thank you for joining the webinar. First of all, welcome to Pioneer Business Solutions webinar on Docker. Please give me 1 minute to introduce to who we are and what we are. We are called Pioneer Business Solutions. We are basically corporate training providers for various organizations across India, and we deliver training programs in both technology and soft skills area. In in technology, we provide trainings on data science, mobile and web technologies, cloud computing, cyber security, testing, programming languages, AI, ML, big data, full stack networking, automation. Uh, And when it comes to soft skills training competency, we provide trainings on business skills, first time manager, personal improvement, leadership, problem solving, time management, executive coaching, emotional intelligence, design thinking. Like we are definitely delivering on ton of programs to various organizations in these areas all over India. The modes of learning that we have instructor led classroom training, virtual instructor led training, hybrid learning, e-learnings, open house, mentor on demand. Some of the training programs delivered to organizations like Target, Infinite, Tally, Visteon, Nine Lips, Voltec, Anantatech, Trans, Eater, Hexaway. And for today's Docker webinar, we have presenter Jeetu. Jeet is a Microsoft Jitendra Singh is a Microsoft certified trainer having decade experience in expertise in Azure, DevOps, Linux, PowerShell, Red Hat technologies, and he delivered many corporate trainings to various clients as well. And for today's Docker webinar agenda, what is containerization, why it is required, what will be the impact of this with the production environment. We are going to learn all this today. Thank you. Now I would like to pass on to Jitendra, today's our webinar presenter.
Thank you. Thank you, Kumar. Hello, everyone. Good afternoon to the session, to a small session about the Docker. Let me share my screen so that we can start working on it. So before we begin this Docker containerization, there are a few things that I want to discuss with you guys. First, regarding the session. So session is getting recorded. Once the session is over, you guys will be provided with some of the hands-on, some small introduction about what Docker is. And if you guys have the resources, I'm gonna give you several questions which you can try to execute. If it works out, that's good. If it doesn't work out, no need to worry. After few days, maybe 1 or 2 days, maybe I will be sharing the solution also for that, so that you'll be having a proper experience on what exactly you have learned in these 2 hours. Okay. Now, Docker is something which cannot be completely covered in next 2 hours. So this is just the overview, how exactly it works. And I have prepared PPT. Believe me, I'm not a PPT guy. Okay. So with that, I have prepared some practicals also for you, where I'll be actually showing you how exactly things are working within the Docker environment. Okay, so this is all about what exactly we will be doing within the session today. Okay, so before we start working on these things, uh, before we start with anything, am I audible to everyone? Please give me a yes in the chat window so that I can start the session. Vijay says yes. Venkatesh says yes. Vara says yes. Okay, cool. Thank you so much, guys, for your acknowledgement. Now, so let's start with the containers or Docker. Now, this is actually a very cool topic and very hot topic at the same time, because now the IT environment, IT market is actually running towards these technologies. If you go back in 90s, in early 90s, 1990s, at that time, if you want to run two applications or three applications within your production environment, what you have to do, you have to set up individual servers for each and every application. Just a simple example, I want to host a website or maybe two websites. Okay. In that condition, I want two different environments. One is going to be the Windows based or Windows hosted website. The other one is going to be Linux hosted website. Now, obviously, I cannot run both of them in single machine. So obviously, I need two different platforms. Or to narrow down the things, I'll say, okay, let me run two Linux environments only. But again, I need two different operating systems maybe over there to deal with my application. If they are heavy level application, if they are quite big applications. Okay. So I'm only talking about two applications, and none of the production are only running two platforms or two environments. They are having so many other applications as well. So there the number of system increases. Then we got to entered into the virtualization era. In virtualization, what happened? You started utilizing the hardware on 100% scale. You started implementing virtual machines within your environment. You started creating virtual machines which will be having their own operating system, which will be having their own applications and everything. This is quite feasible. It is quite easy in comparison with the older method where you were dealing with multiple systems for multiple applications. This is much easier thing. But again, the same problem arises, resources. You are utilizing all the resources and you are not able to completely get the complete, or you can say 100% efficiency on all the applications. That is the reason why this next technology shift happened called containerization. So what happened is in containerization, basically you started building your own container. If you know what container is, it's a simple, I'm not talking about technology container. I'm talking about a simple container that you use in your house. Basically that container contains everything. Okay. Either it could be one single entity or it could be multiple entities under one single container. That's the same thing what we have under our Docker containers. So here basically your hardware will be same. On top of your hardware, you will be just installing a Docker engine or any containerization engine, and then you will be just utilizing your containers. Okay, I'm just taking the overview over here. We have a lot of things to work on. We have a lot of things to talk about today. Okay, so let's see what exactly it is. I hope the picture is clear what exactly we will be learning over here. Now, so basically, so today's agenda is gonna be that we will be starting with the introduction to the containers. Then we'll be looking into the major difference between containers and virtual machines. Still, people are confused that when we already have virtual machines, why do we need containers? There's a big reason why we need containers. So we'll be talking about that. Next is some specific terms regarding Docker. There's something called as Docker, something called as Docker images, something called as Docker Hub, something called as Docker file. What these things are, we will be practically looking into each and everything today. Okay, I'll try to cover as much as I can. Okay, so don't worry about that. Then we'll be building, as I told you, we have some practicals lined up. So we'll be building our own containers also. Okay, so these are the basic introductions about what exactly Docker and something related to Kubernetes will be also looking here. Okay, this is just the overview. So let's deep dive into exactly what is virtualization, because it all started from that particular point itself. Okay, so can I quickly get the small definition in the chat window about what is virtualization? I just want to know that whether you people are aware, whether you people are working on it or not. What exactly is virtualization? I just need one liner. Okay, no need to write the entire story over here. Just one liner would be sufficient. What is virtualization? Come on, think. You all are IT people. Creating resources on rented hardware. Okay. Resource utilization. Okay. Virtual or different environment on a same system. Okay, acceptable. Okay, so Arfat says creating resources on a rented hardware. It's not now here if you are talking about renting the hardware. So basically, this definition comes when you talk about cloud. Now here, if you talk about my local machine, let me just quickly give you the overview. My own machine is having a Linux operating system over here. I am running Windows of environment, and parallelly, just to show the practicals, I'm running some Linux environment also. So it is not always rented, but yeah, up to the mark, your definition is also correct. Okay. Creating virtual instance of any computer. Okay, Madhu, that's correct. Use the feature of physical machine across multiple virtual environments. Wow, nice. So now I got the idea that you guys actually know what virtualization is. Okay, thank you for your comments. Now, basically, other people who are not still clear about what virtualization is. So basically, when you talk about virtualization, it is the method, it's a technique of running multiple operating systems, single, either it could be single or it could be multiple operating systems on one single OS. So base layer is gonna be your own operating system, and then on top of that, you'll be having some sort of tool. Okay, what is that tool called, guys? Any idea? Quickly. See, I want the response in the session, please. It's not gonna be one-way video, please. It is gonna be a responsive one. So I want you guys to engage. VirtualBox, okay, that's the application name which is using that Hyper-V. Okay, again, it's the same thing. Hypervisor. Yes, Ashish, that's correct. A hypervisor is the tool that we use to achieve virtualization. Okay, if you guys want, make a note of it if you like it. Hyper-V is the tool. Okay, otherwise, anyway, the session is getting recorded, so no need to make a note of it. Hyper-V is the application, okay, but hypervisor is the tool. Hypervisor is the tool which is basically used to achieve virtualization. Now, hypervisors are of two types. They are again categorized. Okay. And this is the category name that you are taking over here. So let me quickly take out the notepad so that you guys can understand what exactly I'm trying to explain. So basically, hypervisor is the tool. Okay. It's the method. Actually, it is the tool. And here it is of two types. When you talk about types of hypervisor, one, it is gonna be the type 1 hypervisor, and the other one basically is called as type 2 hypervisor. Type 1 and type 2, these are the two categories. Now, type 1 basically is called as bare metal hypervisor. In short, I'll be writing bare metal hypervisor. Why it is called bare metal hypervisor? because it is directly installed on top of your bare metal hardware. Assume the situation. You went to market, you purchased a fresh branded, completely new empty server. Okay, you brought it to your home and now you install a tool on top of it. That is basically a bare metal where the application, where the hypervisor is getting directly installed on top of your hardware. Then the other category is basically called as type 2, which is basically called as guest based hypervisor. It requires an operating system to work. Best Simply, guest based hypervisors are the hypervisors which directly gets installed on top of your operating system, not hardware. So this time it is going to be hardware, then operating system, and then your tool. So I'm not very good in painting. In school, uh, I did not get good grades on painting, but I'll try to explain it over here. So here you can assume something like this, that this is your hardware layer in the end. That's your hardware layer in the end. Then what you're doing over here directly is you are installing the hypervisor tool. Hypervisor tool. This entire situation, this entire scenario is basically best suited for type 1, because what you are doing, you are installing the hypervisor tool directly on top of your hardware. What is the advantage? Advantage is very simple, that you can directly run multiple virtual machines on top of it. You can directly run multiple virtual machines on top of it. This is your type 1 hypervisor. I'll take the same example and that's your hardware layer again in the end. Then on top of that, you're going to install your operating system. Now, this operating system could be anything. It could be your Windows 10. It could be your Windows Server 2012, 2012 R2, 2016, 2019, 2022, anything. Even your Linux operating system also. So here what you're doing, you're installing the guest operating system on top of it. Then what you're doing, you are installing a hypervisor tool on top of that. So this time it is gonna be, oh, come on, hypervisor tool you're gonna install on top of this. And then you will be simply creating your own virtual machines over here like this. This is your type 2 hypervisor. Okay, so these are the two different categories. This does not require, actually it requires operating system, but the hypervisor tool itself contains your OS. The OS size is very small. It itself contains the operating system. That's why you don't have to individually install an OS. You install operating system over here, type 2. Now, what are the different examples of type 1? So basically, when you talk about the examples of type 1, under type 1, we have VMware ESXi, we have Zen Server, and we have Microsoft Hyper-V. We have Microsoft Hyper-V. So these three are actually the production level hypervisors. In the big companies and big giant organizations, these are the things. Either one of them, maybe all of them will be utilized over there. Then talking about the guest based. So here, if I say the example is very simple over here. You have VMware workstation that you can download from VMware website. You have Linux KVM. You have Oracle, not that, Oracle VirtualBox And then ultimately you have Hyper-V again over here. So remember that Hyper-V is the only hypervisor which comes under both the categories. Okay. Hyper-V is the only hypervisor that comes under type 1 and type 2. Remaining, these are directly downloadable. One of the live example is here. You can see VMware Workstation is written over here. Let me magnify so that it can be clearly visible to all. You can see here VMware Workstation. Okay. Similarly, I have Hyper-V also available on this machine, but both of them cannot run parallelly. Okay. So either VMware will work or Hyper-V will work. So just the additional information you should be knowing about. Okay. So this is what you should know about the hypervisor tools. Now coming back to track. So basically, virtualization is nothing but the method or technique to run multiple operating systems on a single host. Okay, you can run multiple operating systems as I have explained it over here. And basically, what it does is it eliminates the additional need when you're already running two VMs, three VMs on your single operating system. Why do you need additional machines to manage? Simply, you are saving your cost over there. So that's how virtualization basically helped you out. So what is a virtual machine? Basically, on top of your hypervisor tool, you can see here in the example in the diagram over here, you can see this is the basic infrastructure of your VM or virtual machine. Okay, so here you are installing your hypervisor tool. It could be anything. See, I am not specifically targeting one single hypervisor. That's why I have simply written here hypervisor. Otherwise, I can simply go with VMware or KVM or anything else. It can be anything. Every hypervisor is having their own pros and cons. You have to work on that. You have to find out what exactly is best suitable for you. Just one simple difference I will provide here. It is that when you want to, when you don't want to pay anything, but still you want to work with everything, simply go with Oracle VirtualBox. Otherwise, VMware Workstation, you have to pay for its license. So this is only one single advantage or disadvantage you can say over here. Okay, that's why I did not categorize them. You can use whatever you want, but it works in the same way. They all provide you a running guest operating system on top of which you can simply run your application with your data, your libraries, your binary files, or whatsoever it is. And you can completely run this entire individual architecture over here. This is only first VM. This is second VM, and this is your third virtual machine. Again, how many you can run if you're thinking, that is all dependent on the overall capacity of your infrastructure. You have only 4 GB RAM on your laptop. Sorry, maybe you can only run one VM. You have 16 GB. Possibly you can run between 5 to 10 VMs. Again, depending upon how much capacity you have already provided to these VMs. 10 I have written at max, including each and every VM will be having 0.5 GB of RAM, like that. So I have to cut down each and everything properly to manage multiple VMs. If you are running a complete server, which actually happens in the production environment, this number can go beyond 10,000, 10K also. So again, depends on what exactly is your requirement. So virtual machines are nothing but the heavy software package. Now, if you look at the virtual machine over here at this particular instance itself, here, the one thing we need to focus is the guest operating system. Means you have your own operating system available at this location right now. Okay. And I don't have to tell you that how much size an operating system can be having. You can completely have, like, if you are running a Linux operating system, it could be 8 GB minimum. If you are running a Windows operating system like Windows 10, Windows 7 maybe, it can have up to 20 GB or maybe more than that. So we are talking in terms of GB now. The size is increasing. That is the reason I have written the keyword here called heavy software. And it is 8 GB or 20 GB is only the size of the operating system. You install applications on that. Imagine you have to play a game, for example, Counter-Strike. Counter-Strike source basically will have at least 10 GB size. It's just one simple example I'm taking because I'm a pro gamer also. At least 10 GB. So 20 plus 10, 30 GB of operating system having your application. Imagine moving 30 GB every time from here and there, how much it is gonna be. So it is gonna be very risky for you, in short. Then if you move this particular VM to some other location, you have to match the CPU, disk, and networking device or whatever hardware you have attached to that particular VM. You have to manage all those things. So ultimately, it gives you a quite heavy size. The virtual machine basically gives you a very high size. Okay. Same thing, virtual machines may also include the complementary software. Okay. So basically, these virtual machines will have their own hardware and software. And in case if you have to replicate the same thing, you need to build everything again from the scratch. Just a simple example in what actually happens in the production environment. You will be having a dev team, okay, developer team, and you will be having maybe a testing team, okay. So assume that your developers built each and everything on their laptop. They have built everything on their laptop, including the operating system, the application, and binaries and everything. They simply packaged everything over here. They move data to this particular point. Then again, the testers might have to rebuild the same thing from scratch. They might have to do the same thing. So again, the workload increases over here unnecessarily. How to rectify that? It is coming in the upcoming slides. Okay, how you can simply rectify that particular issue. But this is all about the virtual machines. So that's where the containerization kicks in. Okay, that's where you will be using the containers. Okay, so what we have understood about the virtual machine, it is a heavy software, heavy package that will be having all the operating system and its required libraries and application, and then we simply work with it. To reduce this particular size, this example I've taken of 30 GB, to reduce this particular, we can use the containers instead. So before we jump into containers, what exactly containerization is? So containerization is basically the package of whatever you need. Simple. It's a small package. Remember that. It's a small package that contains everything in it. Why there is a difference? If you are thinking, the difference is when you talk about a virtual machine carries the entire packages in itself, including operating system, system binaries, user binaries, everything, application and everything. But when you talk about container specifically, container contains only the application and the data that is being used. Now, if you're thinking, Jitu, what about the operating system? So basically containers borrow, you can say in easier terms, you can say containers borrow the operating system or uses the operating system on which it has been deployed. Whatever operating system, the base layer operating system you are using, it will be utilizing the same OS to work with that particular application. So that is the basic concept of containerization. So if I read this particular thing, containerization is the packaging together of software code with all its necessary components like library, framework, and other dependencies. Nowhere I have listed the operating system also. Nowhere I listed that because it does not carry. Okay. So that's what you have to remember. So a container is a standard unit of software that packages up code and its dependencies so the application runs quickly and reliable. See, when the operating system itself is not available, you know that you're gonna borrow that. You're gonna simply ask the guest operating system to borrow their operating system to work with it, and then you are gonna deploy your application. You will be only carrying the required framework and dependencies for your application. You need not to worry about the operating system. Okay, so that is what the containers basically provide us. To understand basically the difference between containerization and virtualization is this particular difference. So on the left hand side, my left hand side, I'll write here L so that you guys will not get confused. This is the left and this is the right. So on my left hand side, you can see you have the virtual machine option available over here. Okay, it's a name. Basically, we are talking about the virtual machines over here. On top of that, you have the infrastructure available. Okay, 16 GB RAM, 1 terabyte hard disk. I'm talking about a simple personal laptop or desktop, you can say. In the production scenario, this is gonna be a big infra, 240 cores and maybe 500 terabyte of RAM and petabytes of storage. The same thing grows very well. So that's the infrastructure. It will be completely varying. Okay. Next is the hypervisor. So either it could be type 1, it could be type 2, depending upon what you want to use for your infra. Okay. Then you'll be having the VM itself will be having its own guest operating system. It will be having its own binaries, and then you will have to deploy application on top of that. That happens within your virtual machine. But here what happens in containers, you will be having the same infrastructure. Obviously, you're not gonna drop your infra. Sorry. Then you will be sorry. Then you will be having your own operating system on top of that. Either it could be Windows or it could be Linux. Okay. Containerization is a method or technology which works for both the operating systems, Linux and Windows as well. In Windows, you have to download software, install it. You know how to install a software in Windows. Next, next, finish, done. In Linux, you have to configure it. How it can be done, I'll be sharing the links with you in the end. There you can simply go and follow the proper official document. It's not big deal. You have to just copy paste the command and it's done. So simply you will be installing some libraries, some additional packages on your machine to enable uh, Docker or enable the containerization on your machine and then simply play around with them. So I'll be assuming that you will be using the Docker for this particular practical. So I will be installing that Docker engine over here on my operating system. Now it could be for Windows also, it could be for Linux also. For this practical, I have taken Linux operating system. Okay. Remember one thing, it is gonna be the same thing after the installation is done. In Windows and in Linux, you have to run the commands. Okay. And it is this particular containerization is a best part of DevOps environment. So in DevOps, major applications are running on Linux itself. So if you are not aware of Linux commands, no need to worry about that. We will be in future, possibly we might have a Linux presentation also where I'll be showing you how the basic command works out and what exactly you can do with Linux. There are tons of things that can be done over there. But if you are comfortable on Windows, no need to worry about that. Simply go to the simply open the application, run several commands, and you are done with it. Okay. Then we'll be working on any of the Docker engine, the container engine. In our case, it is gonna be Docker. And then you can see here, there is no guest operating system available in this particular list. So here you have your own binaries available, you have your own applications available. Now these binaries and applications requires an operating system to work. So what the container engine will do, your application will contain your applications are contained inside the container engine. Your container engine, in our case Docker, will communicate with the base operating system, whatsoever OS you are using. And then your application and other things will be building up over here. So that's how the container works out in the real-time environment. So talking about containers, the containers are on the same OS kernel. We already spoke about that. They'll be utilizing the already available operating system. They're not gonna rerun or recreate everything from scratch. Then there won't be any difference between a container and a virtual machine. Okay, so here you have the better utilization of the virtual machines, better utilization of resources in comparison with the VMs. You will be utilizing it more. Simple example, what we are talking in the beginning, that your operating system will be around 20 GB, something like that. If you are running a container, that will be winded up within 500 MB size. I'll practically show you that. You can see the major difference here. Here we are talking about GBs and here we are talking about only MBs. Boot up is very fast. Virtual machine booting takes time. Hardly 40 seconds, 30 seconds, maybe a minute. Containers, the moment you run the command docker start and then the container name, hit enter, within fraction of seconds, your container will be up and running. Fraction of seconds I'm talking. So that is the advantage of using the containers. In VMs, you have to wait, uh, you have to wait until the entire VM is up and running, then you log in, then you perform your job over there. That's not the case with containers. You can just run the command and sit. Not you can't even remove your hand from the keyboard and it will be up and running. It's so fast and so simple. So practically we'll be looking into that as well. Now you must be thinking that when exactly you can use the containers. What is the correct time to use the containers? Okay, when you should consider, if you are already running virtual machine environment in your production, should you switch to containers? If yes, then in what scenarios you can use containers? That's what we'll be talking over here. So I've written few pointers over here that start time. When priority, when you have a priority of faster boot time, in that condition, we simply go for the containers. So Docker, as we just now we discussed that Dockers typically get started within few seconds, whereas virtual machines take minutes, maybe a minute, maybe more than that, depending upon how many services you have kept enabled when the VM is getting started. Next is efficiency. When you want more efficient environment, basically what is happening is because Docker containers share many resources with your host itself. So it requires less configuration, less space, less RAM, less CPU. That is the reason when you want more efficient environment, you go for containers. Licensing, when you don't want to deal with licensing anymore. In that condition also you can simply go for containers. Now, why is that so? Licensing is almost, or you can say it is free when you talk about the containerization environment, because the applications which are running these containers are open source. Two major things, Docker and Kubernetes, both are open source. That saves a lot of cost. And the most important thing, according to me, code reuse. If you remember a few minutes back, we spoke about the developer developed each and everything, and the tester has to again build up the same environment. Why should I waste my resources over there also? Why two teams have to work on the same thing again and again, every time? Let's create one single solution, which they can use, my first team can use. It can be passed to the another team, and another team can just run it, and they will be having the entire infrastructure up and running. So basically, this is where you can use the containers if you want. Now, before we move on to anything else, I want you guys to tell me when you should stick to a virtual machine, or why you should stick to virtual machine. If you're working on VM and if you understood this container now you should tell me what should be the correct time, or why, in simple terms, why you should stick to the virtual machines after knowing what containers can do. Please tell me quickly in the chat window. Please drop the answers. I'm waiting for you. Come on, guys, please respond back. For heavy servers, the username is not shown over here. It says unknown user. But whoever wrote this heavy servers, containers can build the infra that you can't even imagine on a very large scale. So scalability is not the option. Kaushik says if our application is big, okay, but even containers can manage that also. Containers are very good in scaling up. So the big application and heavy server problem is rectified. Okay, no problem. I'll tell you three reasons why you should stick to containers. Sorry, virtual machines. What is the reason you should not be completely leaving the virtual machine environment, and you should not be completely jumping onto the containers? Reason one is security. That is the biggest reason why all the IT firms pays billions and millions of dollars and just getting the entire environment secured. But security is actually a big concern over here. Virtual machines are more isolated when you compare containers and Dockers. The reason is, I told you, Docker communicates with the host operating system, on top of which the Docker engine is installed. And then, if you remember this particular, below you will be having your hardware, and then on top of that you will be having your operating system, and then you will be having your Docker engine, and then your container will be running over here. So in order to communicate, in order to work, this container will communicate with Docker engine, and Docker engine will communicate with the operating system, the host operating system. The same goes for the other other container also. There will be a container called C2. It also communicates with Docker engine, and Docker engine communicates with the operating system. So ultimately what is happening, in a way, you are sharing the resources. That becomes, it can be isolated, okay, but I'm talking about the general scenario. So virtual machines in this particular, if you compare it with this particular infra, virtual machines are more secured overall than the containers. Reason number two, portability. You can say Linux or Windows portability. So Docker, it's not completely portable. Okay. I can port or I can simply transfer a container, an image. Image is nothing but you can say a software or an operating system. Okay. Just a general term I'm using. So I want to transfer that particular operating system to someone else. That becomes very easy. There are so many things to uh, follow up. But ultimately, that becomes very difficult. These are not as portable as you're thinking. Okay. The third thing, even if you ignore these two things, the third thing is rollback feature. If you want to, if you're using a virtual environment, a virtual machine environment, and you want to do like I do this a lot. Okay, I'll prepare one operating system for my trainings and I'll take a snapshot of it. I'll finish one training. After the training is finished, I'll just roll back to my original state. That's the meaning of snapshot. I can do it n number of times. So what is ultimately happening? I'm saving my time a lot. I don't have to sit and then configure my entire operating system installation. I don't have to do that again and again. Simple. So ultimately, rollback is a good option in virtual machine. Containers, on the other hand, does not offer the same functionality. Containers do not provide the rollback feature. So when you have these three things in the consideration, then in that case, you can simply go for the containers, sorry, for the virtual machines. Next, now this statement, when I worked as a IT guy and I used to uh, develop things. I worked as a developer. I worked as a infra guy. I worked as a sysadmin. I've done lots of uh, things in IT environment apart from training. So when I was working as a developer, I built something, I tested everything, and then I've transferred my entire code to my colleague. And from there, he started shouting, Jitu, it's not working. Then I'll shout from my end, it's working on my machine. You can come and check. So this is a very relatable problem when you talk about the applications within IT environment. It works on one machine, it works on another. It doesn't work on the other system. I had to use these memes. I found out on internet. Okay, so you must be knowing about this particular incident. Don't you think that Elon Musk might have tested hitting the glass multiple times before he actually went on stage and then did that? That's the best example I can think of. So it happens sometimes, okay? The moment environment changes. Now, why it happens? The moment environment changes, even the version of your application changes, everything will be on the line. For someone it will work, for someone it might not work out. Okay. This is the another meme which I found out on internet. Dev says it works on our machine, but op says that's the op's problem now. So this is a common issue when you talk about the IT environment. That's a very common issue. Okay, just to explain one single explain it in one single example. If you say, okay, you are using Windows 10, maybe the downgraded version, and the client and the other person is using Windows 10, the upgraded version, which is completely up to date. The versions will change. Okay, so then in that case, again, the moment you transfer your application, it will stop working. So these things happen generally in the IT environment. So one-stop solution, this meme also I found out very, very crazy. What if I told you we could really have the same code working everywhere? That is what Docker can actually help you with. You write code once and then you run it on multiple platforms. Like for example, there are two different clients. One is using Windows environment, the other is using Linux environment. You have written the code, now you want to share the same code with both of them. So just share the exact code. They have to paste it somewhere in a specific file, they run it, and then their environment will be up and running. So that is the beauty of the container world, where containerization will allow you to perform these kind of things. Jokes apart, let's move on to what exactly Docker is. So Docker is the containerization platform that package all your application and dependencies into the form of a container. Whatever we spoke, it's written over here. So basically, Docker will allow you to select your own operating system. It will allow you to write your own code. It will allow you to run your own application seamlessly without any problem. Okay. So Docker engine, Docker contains containers that run on the Docker engine. So what exactly, what kind of things you can run basically, what containers you can run basically on a Docker engine. So I have mentioned over here, you can have the standard containers, you can have very lightweight, and then you can create your own secured infra as well. So when I say standard, so basically you can create your own portable applications and everything and make it as a standardized, and anyone else can use that also. Then you have your own lightweight applications. So basically what will be happening is you'll be having only the application and whatever dependencies required under the container. Rest all it will be utilizing from your base host operating system itself. It will borrow all the other resources from the operating system itself that you have installed actually. And then you can have your own secured Docker engine as well, your Docker container as well. So basically you can have your own applications, isolated applications, which will not be sharing anything with any other container. You can isolate them completely and you can make sure that your container do not communicate with the other containers as well. It can be configured in such a way. Okay, so you have to just make sure that you remember these things, that what all things actually you can, what kind of containers you can create within the Docker environment. So I think we have already spoken about this Docker, why Docker is required, okay, why containers are required. So basically it is allowing you to simply create a universal package that can be used or that can be run on any other Docker engine as well. Basically, Docker engine enables the containerized apps, applications to run anywhere. Basically, it is gonna resolve the dependency issue. Everything will be contained under one single container, and it is gonna solve the biggest problem. It works on my laptop. Just now we spoke about that. So basically, this is what we will be having the advantage of using the Docker containers in our infrastructure. Okay, so I hope everything is clear till this particular point to everyone. Now, Docker engine. So we are talking about Docker engine, Docker engine a lot. So what exactly this Docker engine is? And basically, I'm gonna talk about the basic architecture of what exactly or how exactly it looks like. So Docker engine is gonna have these kind of different components which will basically allow you to create and manage your own containers and then simply play with them. Okay, so to access your dockers, you can use the APIs, you can use the command line. We'll be working on command line in this presentation, in this session today. You can also install new plugins and then you can simply work around with them. So in a way, you can run the entire infra as and when you need it. You can configure it in whatever way you want and then simply work with them. Next, terms used in the Docker. Now, if you are new to this Docker environment, then there are few things that you should be very much clear about what exactly you're gonna use over here. Okay. So before you start working on anything, obviously you try to understand how that environment works out. Okay. Same thing happens here. There are few terms that you should be knowing before you actually jump onto the Docker. So this is the overall picture. We'll be talking about that in the end. Okay. Because again, you can see here, if you generalize this particular image, there's something called as a Docker file which does something. I'm just talking about the overall. Okay. Again, I'll come back once we discuss all the terms. Again, I'll come back to the image so that you can understand what actually is happening over here. So this Docker file will do something. It will create something called as Docker image. You can push it to something called as Docker hub, and then you can run your own containers. I know it is not clear, not an issue. Ignore it for now. Let's first talk about the terms that we have. So first we have is the Docker image. First term that we have is a Docker image. So Docker image is nothing but sequence of commands written in a file, or you can say Docker image is something that's get created using the sequence of commands written inside the file called Docker file. So basically what happens is Docker file creates the Docker image. Now, what is a Docker file? To understand that, it is very simple. Now, Docker file. So Docker file is actually the set of commands. Docker file is actually the set of commands that you want to use within your container. For example, just consider the Docker file as a configuration file. This Docker file will be having a set of commands, series of commands that will be executed one by one. And whatever you have written inside that, those things will be happening automatically for your container. So just a random example I'm going to take over here. Like I want first, if I take the Linux example, I want the moment Linux operating system is available, I want here maybe update all the packages. I want to update the entire operating system. Update operating system. Second thing I want to do is I want to install something. So for example, install Git. Okay. Maybe I'm gonna run commands on Git over here. So install that. Then third command, then fourth command, then fifth command. Like that, it will be like that only. I'm just writing it over here because of less space. But you'll be writing all the commands one by one next to each other. This entire thing, you store it under one single file called as Docker file. Now remember, this Docker file D must be capital. There's no extension required. The file name is gonna be Docker file and the D must be capital. You store everything under one single file called Docker file, and then you simply run it, build it. Build what? Build your own Docker image. You'll be writing the entire Docker file content to create an image. That's what is given over here. Docker file is actually creating the Docker image over here. Next term is Docker containers. So Docker containers are the lightweight solution for your virtual machine. Whatever you can do within the virtual machine, the same thing, you will be doing it under the Docker container. So what we do over here, we create file. This is going to be number one. With the Docker file, we generate the image. Number two, with this image, we can create n number of container, not only one, n number of container. That's gonna be a number three. Okay, so Docker containers are nothing but the lightweight solution to your virtual machines. Next, number four, Docker Hub. Docker Hub is actually the online repository. It is the repository which will be having all the Docker images. Okay, so that is the reason what image you have prepared over here, you can also transfer it over here. Just understand with this one example, I know it is completely irrelevant, but assume this Docker image is like your Google Play Store, or whoever is using iPhone, Apple Store. All the applications are available over there. You can create and you can upload your own application, and you can download the application which was created by someone else as well. That's the simple usage of your Docker Hub. So Docker is the containerization application, and Docker Hub is the online portal. It's a platform which can be accessed on your web browser, which contains all the images in it. Simple explanation. Next option is Docker Compose. So basically, when you have multiple Docker container running under one uh, single server, you can use. Mahesh wrote, can we run Docker image without pulling from Docker Hub? Okay, Mahesh, yes, it can be done. Pulling the image from the Docker, it's not completely mandatory. If you have your local images available, you can directly work on it. But to make sure that your local images are also available, you have to again connect back to the Docker Hub itself. So you can create your own custom images without interfering with the Docker Hub. But to get the base environment, you have to connect with the Docker Hub to download the base image and then populate or prepare your own data. Next is Docker Client. So basically, Docker Client is the command line tool that will allow the interaction of user with your tool. So basically, these are the different. One more is there. Yeah, Docker daemon. So Docker daemon is nothing but the background service running that manages the building, running, and distribution of the Docker container. Docker daemon is actually gonna do all the heavy lifting. It's gonna manage, it's gonna do everything that needs to be done that you want to perform on your Docker platform. Okay, so now if you want to understand the entire diagram, so you write the Docker file, you write all the configurations that you need, then you prepare your Docker image with the Docker file, then you create. Now here, either if you want, like for example, if I'm a developer, okay, if I'm a freelancer developer, for example, I'm developing solutions for the entire world. Maybe there are several developers who are sitting and doing this particular job. Actually, they are developing solutions for everyone. So what you can do, you can push the particular image onto the Docker Hub directly over here. But if you want to have your own closed or isolated environment, you want to run your own applications, you can directly go over here as well. So from Docker image, you get the option, both the options, you can go to this, or you can do this, or you can work on both of them also. It's not like I can work, I can create containers, so I cannot upload it on the hub. No, you can create image, you can create containers, verify, validate them. Once they are up and running, then you can push it over here. So all the options are now open for you, how you want to deal with them, how you want to manage them. Now, next is how a Docker container works. So what I have done is basically I have taken an image over here, which basically explains the same thing what I have just now told you in the previous example. So here you can see I have different uh, scenario, different modules available over here. I have the project code. I have the Docker image, means the virtual machine or the container which I'm running. I have the Docker hub available. Then I have the either staging environment or my production environment. All these things can actually be very helpful when you talk in terms of the real prod environment. How basically it works out. So what will be happening is, first, a developer will write the code over here. I told you Docker file is what we create, we generate. Okay. And with this, what happens is we generate the Docker image. Whatever code is required, everything will be written under one single file. Everything will, I'll write whatever I want in my environment, in my container. I'll put everything under one single Docker file. And with that, I will create an image. I'll build an image. I'll build an image with this, because from the image, now I can create a container. I can then validate and test if everything is going good. I can simply work with this container if it is only the isolated environment. Or if you want the other environments of your same production house wants to use this particular image, so you can push it to the Docker Hub repository. Now, Docker Hub repository comes in two different variations. One is gonna be the public repository, which, as name says, it will be public for everyone. And then the other one is gonna be the private registry or private repository. This private repository will be only and only accessed by the organization, or if you are the paid user of that particular thing. So generally, whatever developers do for building the things, they generally go for the public repositories. But again, this is not the thumb rule that they will only choose public repositories. No, if my organization wants to build a complete isolated solution, I will build an image under the private registry. Obviously, for that, my organization will be paying something, but that is not on my head. That will be the company's headache. So I have both the options. Once it is available on the Docker Hub, then developers or people from the staging environment can directly pull this particular image and then start doing whatever they want. So see here, whatever I wanted, again, my staging people are not building it again. They are not doing it again. The redo work is completely eliminated. Once they have verified, okay, everything looks good, they'll send an email to the production team that yes, our servers are up and running, you can deploy the same thing. They can also again pull the same image, and then they can start building the servers or whatever it is there. So ultimately they are saving a lot of time over here in not building the same thing again and again. If you remember code reusability, we are reusing the same code written in this particular stage. That is how Docker container works in the actual environment. So I hope this is clear to everyone till this particular point. Now I have created, or I have some practical setup for you. We'll be directly working on that, enough with the theoretical part. Obviously, when we have seen so many positives of what Docker can do, why not let's verify that? actually these things work in the same way. So let us directly jump onto the practicals. And before we jump onto the practicals, I have few prerequisites that you can also use if you try to replicate the same thing after the webinar is over. So here what I have done is I have already created a Docker Hub account. Okay. Simply go to the website called hub.docker.com and you can create your own Docker Hub account as well. It's a free account creation procedure. It's more than easy than creating a Facebook account also. So you can directly go over there and simply create your own account, Docker account. Then I am using a virtual machine. Okay, to perform all the practicals, I'm using the Azure virtual machine, Azure Ubuntu. Azure Ubuntu VM to basically perform all the practicals that I want to show you. Okay. Also with this, I have a local VMware workstation virtual machine because from this Azure Ubuntu VM, I will be creating the image and then pushing it to my Docker Hub account. And then I'll try to download the same image under my local virtual machine. That's what I'm gonna do over here. One more thing you need is a simple high speed internet. Okay. So even if you have 3G or more than that, it is okay. It is fine. Okay. So these are the several prerequisites that are needed for your practicals. So before that, let me jump on to the Docker Hub, and this is how the Docker Hub looks like. Okay. hub.docker.com. That's the name of that is the URL. Okay. And here I have a repository with the name called tomerj44. Okay. So you have to give a repository name when you are signing up over here. It's like a unique name. Like in Instagram, you provide some your handles. Like if you want to find me, I will be having some handle where you can search me out over here. Same thing happens over here as well. You can create your account and then you can simply work with that. Creation is very easy. I'm not gonna show you how to set it up. Just go to hub.docker.com and then you can simply fill the details over there. You can see here I have an image available over here called test CentOS or CentOS. Okay. Before coming to this, I tried some practicals because technology is upgrading day by day. So it's better to always be prepared for all the unexpected. IT is all about not expecting anything. So it's better. I do this every time. So I already have an image available here. I can remove it also. I will be removing it later on once my practicals are over. Okay, so that's the Docker Hub. Now I will be jumping onto my machine. Before that, let me quickly open the tool which I will be using for connection. So for connecting to my Azure Ubuntu virtual machine, I am using, oh, come on. I am using MobaXterm, a utility which basically gives the access to any Linux, Azure, AWS, any platform that you want. I feel quite comfortable working in this environment. You guys can go for Putty also. Okay, there is another tool called Putty that you can use and then simply you can follow the same practicals later on. Don't worry about the commands. I have already prepared a set of instructions, what needs to be done. That's a separate file. I'll be sharing it with you also after the session will be over. It will be attached in the email with the video link, question, which I told you in the beginning that I'll be giving you an assignment, and this particular step-by-step guide, which you can use for performing the same practicals. So here what I have done, another thing, what I have done on these two Linux machines is that I have already installed Docker over here. Docker is already, Docker is installed. It's already installed over here. Okay. It's not something quite heavy that you cannot do. You can simply go on internet and type how to install Docker and you'll get the step-by-step guide over there. Okay. So how to install it, even the steps are available in the guide as well. You can simply just follow the same thing. Now, before we jump onto anything else, now this is something which this is a VM which I used for several environments and several things. Now I want to know actually the Docker is available here on the system or not. How can I test that? There's a command simply called Docker space info that provides the detailed information about everything that Docker knows, including how many containers are running, how many containers are stopped, how many of them are paused, how many of them are downloaded. Everything will be available under here. When I type this, hit enter, it gives me a huge list. Verify this. So it is giving me a huge list. You can see here client default, plugins, then you have the server. I have 11 containers available over here. All of them are stopped, 14 images available, and other things also lined up over here. Only 2 CPUs are there. If I want, I can increase it also. But in 2 CPUs only, I'm getting everything what I need over here. 2 CPUs and 8 GB RAM VM I'm using over here right now. Okay, so simple. No rocket science. It is just giving the simple Docker information. Now we spoke about Docker images. Let me show you images on the Docker Hub. Like for example, I want, or my production environment requires Apache web server to be up and running. So what I can do, I can simply search for Apache and there we go. You can see here HTTPD Docker official image. You can directly use this image. You can pull it in your account and then start working on it. You have the Tomcat, Maven, Zookeeper, Cassandra. So many things are there. Just have a look. I just wrote one single keyword called Apache and check what I've got. And check this out. 50 million downloads. 1 billion downloads. You can see it is the official Docker website. I'm not building the things over here. So people are using these things. When the things are already available, why you have to waste your time in rebuilding the same thing? That is the whole purpose of Docker. People are creating, uploading it in the Docker hub. You, on the other hand, requires it, download and use it. That's what is happening over here. So these many images you can see here. Operating system also you can select. You want Windows based, you want Linux based. Architecture also can be selected over here. You want the trusted content only. You want some extension plugin or the images. Filter down the things and you'll get what exactly you're looking for. So here, if I want to check what all images are available on my system, so simple command is docker image ls for listing. Enter. And you can see here, I have these many images available on my system right now. If you look at this bottom, Ubuntu is written. I wanted to show you the things which we have actually theoretically studied. Ubuntu 14.04, 19, it was created 19 months ago. I never created that. Someone else created. I just downloaded that image on my computer. and it was built 19 months ago. You can have a trace also, like when it was actually created. You can see one image is 19 months ago and one image is 6 hours ago, which I have built. This test CentOS, which I have built actually. So see the size also, 196 MB. We were talking about heavyweight and lightweight. That's what we were actually talking. The entire operating system which I developed and created is just under 910 MB. That's the lightweight thing we were talking in the beginning. There is a default image for the beginners called Hello World, which is only of 13.3 KB. Have a look. I'm not bluffing over here. Check this out. It is 13.3 KB. So if you want to verify if actually the Docker is running on your platform, on your system, you can just run this particular thing and it will show you. What it shows basically, Docker. Let me delete that image RM. I'm gonna delete it because I want to show you again how it works. Okay, sometimes you need to forcefully delete them. Now if I verify again, there is no hello world image available. You can verify. Okay, now check this out. Docker run, not run, Docker run, or I need to pull the image. Docker pull. I'm gonna pull the image from the Docker hub. So Docker pull hello hyphen world. This name could be anything. Okay, this name could be anything. What you are trying to search over here, that name you can directly write. And if you want to actually want to know what exactly you have to write, for example, I want this HTTPD. I'll click on it. Check. Let me magnify. Pull command copied. So you can see here Docker and then pull and then the name that actually you want to pull from the Docker hub. That's what I've done over here. Enter. See what it did using default tags. Now tags are nothing but different versions. If you talk about Ubuntu 14.04, 16.04, 20.04, and so on. So which exact version you want, even that can be directly available over there. It's not showing, it is already available over here. No problem. I can show it. That's the reason I created another VM. Docker pull hello hyphen world. It's a VM, so possibly it is, that is the reason it is taking time. Check. Ah, there also it's like it's already existing. Cool. I will use another image, HTTPD, which I've just seen in the portal. Possibly this is not available. See. So what it is doing right now, it is pulling that particular image from internet in broken parts. It's pulling the particular image. You can see here 1, 2, 3, 4, 5 parts. It broke down the entire image in 5 different parts and then it downloaded the image onto my machine. Easier way. I'm not sure if you have heard of an application called IDM, Internet Download Manager. Even it used to do the same thing. If you want to download anything, it will break the particular application or video or audio or ISO in multiple parts, and then it will download everything onto your system. That's actually much safer way. You can see here, downloaded new image HTTPD colon latest. HTTPD is the name of the image on my system. colon latest is the tag. That means I have downloaded the latest HTTPD image. And if you want to basically check what all images are available, you can simply go for Docker image ls. See, HTTPD latest. There's some ID. There will be always some ID associated with your uh, container or your image. Okay, because you can download them multiple times, and every time it is gonna be something different. Check this out. It is only 145 MB, and Hello World, which is already available over here, it is 13.3 KB. That's the simple advantage. Okay. Now, here you can simply see how easy it is. Now let's move on to another practical. Okay. That's how basically you can download the image from the internet. Now, once this is done, let us download one more image, Docker pull Alpine. I think it is already there. I'm just checking it. It is already there. Okay, Docker images, image ls. You can see Alpine. It's already there. So what I've done, I've already downloaded this image on my system, and now I can use this particular image. The image is already there. I have not prepared it. I'm using the predefined, which is already available to me. Okay, we will be building in a while. Okay, we will be building our own image. But for now, what I want to do is I want to run my own container using this Alpine image. Alpine is a type of Linux operating system. So to do that, Docker run command will basically run a new container for you. I'm going to use the -it option, I for interactive, T for terminal. If you don't do this, container will be up and running in the backend and you will not be able to interact with the container. Means you can't do anything else to your container. But I want to interact. So simply what I'm doing, I am passing this IT option. So whenever you want to log into your container and work with it, that time you use the -it option. Image name, it is gonna be Alpine, and I'm passing a shell here /bin/sh. I'm passing this shell here. Hit enter and check. What happened? Earlier I had root@docker demo so and so, docker run so and so. Now what is happening? My entire prompt got changed. If I do this, who am I? It says it is root user. Host name. Am I on the same computer or it is a different system? Check. I'm getting some random number over here. That's the image name, the host name actually, which the Alpine is using right now. So what is happening? I am inside Ubuntu, and inside Ubuntu, I am running an Alpine container. To understand this using the graphics, so what I did, I created this Ubuntu image. I created this Ubuntu image. Inside this Ubuntu, what I did, I installed Docker Hub. Sorry, Docker. I installed Docker. Okay, my Docker engine is running over here. That's the Docker engine. And then inside this Docker engine, what I'm doing is I am running a container. It should look like a container. The container base operating system is Alpine. That's what is happening right now. And I am inside this Alpine machine right now. So here I have logged in and now I can do whatever I want. I don't want this. I can simply exit the console from here. Now you can see when I type exit, the host name also got changed. If you want to check the host name of my Linux machine, which I'm using, it is Docker demo. Earlier it was this number over here. So what I did, I entered into my Docker machine and then simply I came out of it. I could have done whatever I want. I can install application, I can run VM, I can create files, directories, whatever I want. But in so simple manner, I got my entire environment up and running. That is the advantage of using the Docker platform. Now, if you do this, Docker PS, Docker PS is the command which basically lists all the running Docker processes. You can see here nothing is there right now. It's not, there's nothing in it. Why there is nothing in it? Because when you entered into it, the container spinned up, and when you type exit command, so the container got deleted automatically. Container got deleted automatically. To prove my point, I will duplicate this environment. Just give me a second. What I'll do, I'll run this command again. Right now, PS is empty. You can see container name, image, all these things that is showing over here. I'll rerun the same command here again. I'll go inside the container image again. Check. This time the host name will be changed. See, earlier it was 17EE688 something something, and this time it is 7B3837 blah blah blah. Meanwhile, if I take the same command docker ps and paste it over here, hit enter, there we go. Check. So there is a container ID associated with my container. Which image I am using? It is Alpine. The command which I have executed, it is a shell created 20 seconds ago, and status is up 19 seconds ago. So overall, it took actually only 1 second to spin my container. That is what I was talking in the beginning. And then there is some random name, fervent plot. I don't know how to call that also. You can ignore it. Every time when you don't give a container name, it will take name by itself and it will assign it over here. That's okay. Anyways, I will be dealing with the container IDs every time. Names can be same, IDs will be always different. Okay, so here also you can see the container ID is available. Now maybe your manager says, okay, Jitu, show me how many containers we ran in past. Can we do that? Yes, we can. Simply same command, just add hyphen a means all over here. Hit enter and there we go. Let me run it and show it again. See, there is an image which created 44 hours ago, because 44 hours ago only I created this VM. I ran several scripts, because of that these many things got created over here, but you can see somewhere it says relaxed, somewhere it says objective Edison, blah blah blah, somewhere it says test Ubuntu, because I changed the name basically. Test one, my Ubuntu, test Ubuntu, and all those. So I've changed the name. That's why it is giving some specific names. Where I have not given the name, it has taken some random like dazzling bell. Okay, so all these things can be simply traced one by one over here. You want to run any another image? I'll type exit, same command only, but instead of Alpine this time, I'll go ahead and I'll use Ubuntu. Ubuntu image is already there. Hold on. You can see Ubuntu, 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 Ubuntu. So many Ubuntu images are there. So let's do one thing. Okay, so Docker rm -f, and let's destroy this completely. So you can see here I've taken random images, and if I rerun the same command grep ubuntu, it's empty. And if I check all the commands on all the images again. See, this time no Ubuntu. Alpine, test, hello world, Docker demo, Alpine. No Ubuntu available. So now the image itself is not available, and now also you are trying to run this particular command. Now Docker engine will automatically understand, okay, this is what is happening, and then it will try to pull the image from the Docker hub itself. Type this, hit enter, and there we go. What I did basically, I ran it. I directly ran it. Let's check. Check this out. Ubuntu 12 seconds ago. Ultimately, what happened? It ran the image directly for me, and I am now inside my Ubuntu operating system. I can run whatever I want, like apt get. Like the very first thing in Ubuntu I do is I update all the packages and everything. And there it is. You can see here archive ubuntu.com. So it is communicating with the Ubuntu server, and you can see here fetched 25 MB. I can run another command like okay, apt get install git maybe -y, enter, and there it is. It's installing the package for me. So without interfering with the actual base machine, it is fetching the entire OS and then simply working like this. So you can see here, everything is running properly as we need. Once it is not needed, type exit and you are out of the console. That's how basically it works out. Now, sometimes it is required that you have to run the Docker image maybe in the backend, and then you need to play around with it. So let's do this. I'm not gonna use the IT here. I can use bash. Okay. So right now what I did, you can see here, I came out of the hashtag again. This. So I'm not getting inside the Docker image. I just ran it and it is spinning in the backend. If I do this, Docker PS, you can, okay, it ran and it stopped maybe. Let's check. These bigger fonts I hate. You can see here 25 seconds ago. That is giving the nervous care, some random name it has taken. You can see here it is giving the actual information how things are working over here. Okay, that's how basically it works out in the real-time environment. Okay, you run it, you run the entire code that you want and simply play around with it. You want the detailed information, like you can go for Docker stats command. This will give you what exactly your current Docker utilization is happening. Current utilization. You can see right now everything is empty here because there is no Docker container running in the backend. I'll go here on another terminal and then I'll run another command. Docker run -it Ubuntu, and I'll give some name demo ubu, and okay, I'll remove the name. There it is. Now if I go back, check. So what happened? You can see here container ID. You can see the container ID over here. You can see some name has been given, CPU percentage, how much memory it is utilizing out of. Now see, the point is it is utilizing the memory out of 7.76 GB, but nowhere I have mentioned the memory size. So Again, proving one of my statement that your Docker container communicates with your base operating system, your host operating system. My host operating system is currently having 8 GB of RAM. You can see here, 2 vCPUs and 8 GB of RAM. I'm using 8 GB of RAM. And from here, my Docker demo VM, it is actually utilizing the content, and then you can see here, it's working on it. If I do something like this, not yum, apt hyphen get install hyphen y, maybe, no, not install. Let's first update. See, memory usage 3.9, 8.10 point. The data CPU utilization was going up. You can see the live difference over here. If I just run a command called yes, check this out. 20%, 23% utilization is happening right now. 22%. So it is giving me the live information of my virtual machine over here. Okay, that's how you basically play around with it. Now, if I want to stop this particular container, it's already running. I don't need this anymore. You want to stop this container, you can simply go for Docker stop and then the container ID. I told you we don't have to worry about the name. It's just the ID that I need. Do this, hit enter and wait for some time. It's taking this much. Here it is. So if I go back, you can see here, it came out of it automatically. It came out of it. So that is how you can, now you want to start something, you can instead of start, you can instead of stop, you can write start. And that particular container is now again started. You can simply go back and you can play around with that. So again, completely it is up to you how you want to deal with a Docker container, how you want to play around with it, and then you can do whatever you like over here. I hope this is clear to everyone till this particular point. Can we get a yes or no in the chat window? Now, before we run into anything else, let me show you the Docker file which I told you in the beginning. Okay, so here I have already prepared, sorry, the content for you. You can see here, there is a file called Docker file, capital D, no extension at all. If I use Vim editor, Docker, Vim space Docker file and hit enter, you can see I have written some commands over here. Let me explain the meaning of what these commands are actually doing. So every Docker file starts with the first line from, in capital, from, and then you have to write the name of your image that you want to use. Colon, I have given a tag name. Means I want to use the CentOS 7 to basically work on my application. Once this is done, what I'm doing is I'm giving a maintainer name over here. There's a maintainer name which I have given. Okay. Maintainer name is nothing but who is actually maintaining this particular data, this particular container. So Jitendra space, my email I have given over here, jitendra@pioneerbusinesssolutions.in. So basically what is happening, if someone tries to find out that what exactly or who exactly wrote all these things, he can simply contact me over here. And then I ran some commands over here. I'm writing some commands over here. Yum, make cache, then I'm writing upgrade, then I'm gonna go for install, then git, means httpd git and vim. these three packages I want to install under this CentOS. Maybe there's a requirement for my production environment where I need set of specific tools pre-installed. So what I'm doing, I'm writing one single Docker file and then I'm passing all the information that I need to use. I have used here 6-7 lines only, but it could be 60-70 lines. It could be 600-700 lines, depending on what you want. So you can write this entire code. Now, how this code can be written? For the easiest thing, I'll say you can go to Docker website, Docker tutorial, and then from there you can understand what exactly you need. You don't need much things. You don't have much commands to write it over here. Very limited set. Very limited set is there. You have to just understand what is the meaning of each and every command and run them. Simple. So simply what I did, I can simply save and quit the file. I have not written anything, so I'll quit the file directly. Once the file is created, you can simply now use this particular Docker file to work on it. You can do whatever you like. You can uh, do whatever with this particular single Docker image. You can do whatever you want to do with the same single image over here. Now, simply what I'll do, I'll create a new container. I'll create a new image with this Docker file. Then with this Docker image that will be created, I will create a container with it. So first I'm going to create a Docker image from the Docker file. Okay, I'm just writing it over here. From Docker file, I'll create Docker image. And from Docker image, then I'll create Docker container. That is going to be the objective. Okay, so this Docker file is already available. Now I don't have to write the same thing again. Simply I can write Docker build command. So whenever you want to build anything using the Docker, you have to use the Docker build command -t, and you have to simply give the name of the container that you are looking for. So I'll give the name as uh, Docker webinar. That will be fine. Dot. So automatically Docker build command will understand you have to be in the same location. Always make sure that wherever the file is available, you have to be in the same location. And then you need to specify a dot over here. Okay, so directly what you can do, you can just write this, hit enter and see, check what happened. CentOS step 1 from CentOS, step 2 maintainer, step 3, 4, 5, 6, 7. It did everything over here. Check and successfully built. It has given me an ID, successfully tagged Docker webinar dot latest. Now, if this image is built, that means if I type Docker images command, it should be available over here. Check. Why it is saying 6 hours ago? Because CentOS is already available on this computer. So it has taken the same image and then built it. If it is a freshly new operating system, it will pull everything from Docker and then build it up. So it was quite fast here for me. So when the image is already available, it is just fetching the information and then playing around with it. Simple. That's what I want to do. Okay. Now you don't have to worry about this anymore. You can simply create a container with this. So what I can do, I can create a container using Docker run -it and the Docker name. Why should I write instead when the command is already available? Check. So here I'll use the image name. Image name is this one. Docker webinar so and so. I'm using this particular image over here. Last time I wrote Alpine. Last time I wrote Ubuntu. This time I'm writing Docker webinar. Enter. Check. Now, if you remember, under Docker image, I have installed HTTPD, Git, and Vim. Okay. So let's check. Git double hyphen version. Can you see? It did not give an error. Instead, what it did, it showed me the version. Git double or not Git, sorry. What was the next? HTTPD. Okay. Okay, that's a service. So let's say Apache slash etc slash passwd. See the Apache. Why Apache? Because Apache is the user used for HTTPD service. So even that is available over here. I'll use Vim command. You can see Vim is also installed. So now my image is actually available and I can do whatever I want from this particular image. Even I can I can push this particular image to my Docker hub also. I can push it. This is a customized image that I have created. And now I can simply push this particular image to Docker Hub so that the entire world can start using this image over here. That is what exactly we can do. To do that, what I will do, I'll just exit from here. And this is the last procedure for our Docker. First thing first, I will have to log into Docker. Okay. To push the image, you have to always log into the Docker Hub, the same account, this account which is available over here. So I'll type Docker Hub. Username is visible to all. Password, obviously, I'm not gonna tell. Hopefully I've written correct. Yeah, you can see here, warning, your password will be stored unencrypted. So I'm not going to open this JSON file. Don't worry. Login succeeded. This is the important line for us. That means now you have logged into your Docker container, sorry, Docker hub. From the portal itself, you have logged in. Now, to upload the image, it has to be in the specific format. The name of the image has to be in the specific format. If you look at the image name right now, image name is all just Docker hyphen webinar, means something is there which will not be accepted. It will throw an error. The name has to look something like this, your account name slash the image name. So what I have to do, I have to rename it. So to rename my image, I will go for Docker tag command will help me out. Docker so and so. I'll take the name here, this, and my account name tomarj44 / this colon latest. I have to pass the tag also, whatever tag is written over here. You have to pass that tag also. So if I go back over here right now to my Docker repository, check. I have only one repo available called test centers. I'll refresh it just to make sure that I am having only one single repository available. Check. Only one image. Now I'll go back over here and just upload it. That is for renaming the image. See here. There's a new image here called Tomarj44 Docker webinar. Okay. There's a new image available over here. This image I need to push to my Docker Hub account. To do that, simple command is docker push and the image name. That's it. Problem solved. Enter. And you can see mounted on so and so. Acha, it is already mounted. Okay, let's verify if it is there. There we go. Check this out, guys. The image is now available. The image is now available on Docker Hub. You can see here contains, let me magnify, contains image last pushed a few seconds ago. Another one is few hours ago, 4 hours ago. But here it is few seconds ago. That means live update has happened. If I go over here, I am getting all the image information. Now, if you want to use my image, for example, if you guys want to use it, maybe you want to perform some practical or anything, that's the command. Just you have to run on your Docker portal and Docker console and hit enter, and you are good to go with it. So you don't need to recreate everything. Just write this command, hit enter, and it will pull the entire image. Just to prove my point, before that, you can see there is a latest. Here it is having all the latest updates available. You can click on it and you can simply get all the information. I can go back to my Linux terminal. I'll check the images. You can see here there are only 2 images. Now what I'll do, I'll paste this Docker pull image, because this is going to be happening for the first time and the tag is going to be the latest. Enter. It's going to wait for some time. Just wait. Come on. There we go. It created the big suspense. It is going to fail or what? But now finally it worked. So you can see here downloading complete. It is downloading all the components and then it will simply merge everything together and then it will give me the success message in the end. You can see here extracting the contents, pull complete. Check. It is happening one by one for all the segments. And there we go. You can see status downloaded newer image for so and so. If it is the newer image, earlier we had only 2 entries here. This time, let's hit it and check this out. The same image can be pulled for your production, for your staging, for your QA, anything, and then simply you can play around with this image. You can spin your own container, work with it, and then do whatever you like. Last thing, I can do this also. Docker run -it and then my Docker image name over here like this. Enter. So here, if it is the same image, Git must be installed. Git --version. Enter. There it is. That is all about Docker containerization. So that's all from my end, guys. I want you guys to shoot the questions in the chat. Just five more minutes, guys. You can stop the recording. And if you guys have any queries regarding this, please ask me in the chat. Okay, Kaushik is asking, can we convert back Docker image